Hey, Eric, I was just outside. It's nighttime in Italy, and I was using my CPC Deluxe HD powered by PrimaLuceLab telescope, and you called me. How are you doing?
Pretty good, man. I'm still just waking up and having my cup of coffee. Obviously, there's a time difference here in California from where you're at in Italy. But yeah, excited to go through the presentation with you today.
That's fantastic. I was using that visually, and then I was connecting my camera, and then, well, let's do this. Why don't you start talking about the new version of the CPC Deluxe HD telescope that we developed together?
Sounds great. Hi, I'm Eric with Celestron, and I'm here with Filippo from PrimaLuceLab, and we're here today to discuss our recent collaboration, One Setup to Rule the Night, supercharging the CPC Deluxe HD with PrimaLuceLab. Let's start by talking about the telescope itself, the CPC DX HD line from Celestron. What makes the CPC Deluxe HD exceptional, but what holds it back? So the Celestron CPC Deluxe HD, it's our best fork-mounted Schmidt-Cassegrain designed for serious observers. The optics have an integrated two-lens corrector, which was added to the base Schmidt-Cassegrain design to provide a flat field across full-frame sensors, making it a perfect optical system for all types of observing and imaging. This is why EdgeHD is one of the most popular telescopes used by amateur astronomers today. There were also mechanical improvements made with the addition of tube vents and mirror clutches to increase overall performance. The mount is our most heavy-duty alt-azimuth mount, fully integrated with the optical tube to simplify and provide a very stable platform. It uses our best worm gear motor drive system to provide excellent tracking and performance and is custom designed electronics to run the system. The optics and mount combine to make an excellent system for all kinds of astronomical use, for visual observing, planetary and high resolution imaging. Its compact, self-contained design makes it the go-to telescope for star parties and outreach events. Let's take a step back and talk about the fork-mounted Schmidt-Cassegrain in general. So Tom Johnson, Celestron's founder, developed the first commercially available Schmidt-Cassegrain telescope in the 60s, and it really ushered the rise of amateur astronomy in the 70s with the affordable C8 telescope. Many of the reasons why this telescope has been so popular still hold true today. It has larger aperture, which for visual use allows you to see more detail, and for imaging, it provides higher resolution. It has a very compact form factor, and this is really one of the main reasons why Tom Johnson developed this, because reflectors and refractors become unwieldy to use in larger apertures. So if you want larger aperture to be able to see more and get higher resolution, refractors and reflectors kind of become impractical once you get over about the 6-inch size. The SCT, the Schmidt-Cassegrain telescope, has a folded light path, making the telescope much shorter and easier to handle. So also the integrated fork mount in the alt-azimuth configuration, as you see in this picture here, simplifies setup and operation greatly. And at the time, and even today, it's relatively inexpensive. It incorporates aspherical optics at a much lower cost than other folded optical designs. So that's one thing I don't think many people realize is that Schmidt corrector, that piece of glass up front, is an aspheric lens, which is basically an 8-inch or larger aspheric lens, which if you didn't know the secrets that Celestron knows how to make in production, it can be very expensive to make. So really the process that Celestron uses to make the Schmidt correctors was a real breakthrough in providing aspheric optics, which are a higher level at a very reasonable cost. So the CPC DX HD series is really just the modern version of the fork-mounted SCT. So as digital cameras became less expensive, more sensitive, and easier to use in the 2000s, more and more people were actively using their telescopes for imaging. In 2010, Celestron launched the CPC DX HD line of telescopes. This updated the C8 design to make it more practical for astronomical imaging. There are two main components to the system, the EdgeHD optics and the CPC DX mount. So the EdgeHD optics are really the heart of the system. The aplanatic flat field Schmidt-Cassegrain optics provide pinpoint stars all the way to the edge of a full frame sensor or large eyepiece. The versatile design accommodates 3 focal ratios. Natively, it's f10, but you can convert it to f7 with the optional reducer, or you can do ultra fast f2 imaging with the removable secondary mirror and the StarZona Hyperstar accessory. So it allows you basically the flexibility to image or observe at multiple focal lengths using the same instrument. We added the mirror support knobs to hold the mirror in place to reduce image shift during imaging. The tube vents feature an integrated mesh filter, so hot air can be released from behind the primary mirror, and the mesh prevents dust from getting in there. And it also uses our best coatings to provide maximum light transmission. So really just a fantastic overall larger aperture instrument for amateur astronomers. So here we can take a closer look at the EdgeHD optical design. So the light coming in from the right of the slide goes first through the Schmidt corrector, then hits the primary mirror, reflects back up the tube off the secondary mirror, then through the baffle tube and through the center of the primary mirror, as you can see in the drawing. And there's a 2-lens corrector lens in that baffle tube. You can see at the left end of the tube. And then the focal plane is located to the left. So you can see the light comes through the telescope, through the Schmidt corrector, off the primary, off the secondary, back through the telescope, through the 2-lens corrector, and out the back to your eyepiece or camera. And it's really the 2-lens corrector that provides the flat field performance over the base Schmidt-Cassegrain design. Now, to look a little deeper in the optical design, you can see that, yes, it does have a secondary mirror obstruction, but it's quite small and it doesn't have much effect on image quality or contrast. The image circle for all 3 telescopes in the line, which are the 8-inch model, the 9 1/4, and the 11-inch model, they all provide a field of 42 millimeter diagonal, again, which covers all modern sensors that are used. And you can see that as you increase the aperture from the 8-inch to the 11-inch, you also get the increase in resolution, which is important for seeing the faint details in deep sky objects. Now let's talk a little bit more about the focal reducer. So if you want to convert from the f10 focal length to f7, we have dedicated reducers for each of the models in the line. So it takes your EdgeHD 1 stop faster than f10, reducing your exposure time by half to capture the same object brightness. So you'll get essentially a lower magnification view, but it'll be brighter so that you can basically get high image brightness in half the time that you would at f10. So that's a nice thing. It's a nice flexibility to have if your object is not necessarily tiny. You can sort of step back a little bit and get increased image brightness, which is nice. So when you use the reducer, it maintains the flat field performance of the native focal length and increases the field of view by 43%. So again, if you're shooting wider field objects, like most of the popular objects that people like to image, converting to f7 can be a nice thing to do. So the reducer, to maintain the flat field and the excellent optical performance of the native system, it uses 4 or 5 lenses, depending on which aperture you're using. So you can see that it's not just a simple corrector, it's a more complicated one that's needed really to maintain the flat field performance at f7. It also uses rare element glasses to achieve that. Now, the CPC Deluxe mount is our top performing alt-azimuth mount. It uses our biggest fork arms. It has our best motor drive. And this provides a very stable platform with excellent tracking accuracy. It does have integrated handles, which makes it really easy to mount and dismount And keep in mind, the optical tube stays with the fork mount, which really simplifies setup. It just moves as one unit, and with the integrated handles, it makes it easier to transport and mount. So the CPC DX mount uses our best drive system. And here are a couple images I found off the internet that show it in better detail. On the left is the azimuth drive, which uses a brass and steel gears to provide excellent mating between the gears to minimize backlash. And it also has spring-loaded mechanism to further minimize backlash. And on the altitude axis, it uses brass and steel again, and it's also spring-loaded. So, and you can see I believe they're 6-inch diameter. So very high quality drive system to minimize backlash and provide excellent tracking accuracy. Now you can see the weights and dimensions, and we just wanted to show this just to show some differentiation between the scopes and the line. Of course, the 11-inch is, the biggest, and as amateur astronomers, bigger is typically better. It can show you more. But if you find that you're not using the telescope because it's too hard to move around, then maybe that's not the best choice. So the 8-inch model, the CPC Deluxe 800 HD, is really the most portable and is the one that's most widely adopted, easy to take out into the field, put in your car, drive somewhere, or just use it, take outside and use in the backyard. The 9 1/4 model is still pretty portable. It's only incrementally harder to move, heavier and harder to move around than the 8-inch model, and does provide just a little bit more aperture. The 11-inch is not nearly as portable, and it takes 2 people to move around. So really the 11-inch model might be best suited to somebody that's primarily keeping it in one spot, whether it be a backyard observatory or, mostly used around the yard where you don't have to move it around too much. It's the least portable, and that one's more suited towards backyard observatories. Now, everything sounds great. So what did PrimaLuce do to make it better? Well, there is one weakness that we're going to talk about, and the weakness concerns what's called field rotation. So the one weakness, this really concerns deep sky imaging. So when any telescope is mounted in the alt-azimuth configuration, the field of view will rotate over time as it tracks objects in the sky as the Earth rotates. This causes stars at the edge of the field to become streaked with longer exposures. So alt-azimuth imaging, has this weakness where the field will rotate over time, affecting stars at the edge of the field of view. The traditional solution has been to use an equatorial wedge to tilt the entire mount so that it can be polar aligned, essentially converting the alt-azimuth mount into an equatorial mount. And while this solution works well, it comes with trade-offs. You'll need to lift the mount and telescope onto the wedge. So you have to lift this entire setup and tilt it onto the wedge, which is pretty cumbersome to do. It's not the easiest thing to do. And if you're moving this thing around, it becomes a pain in the butt pretty quickly. The other thing is that you also need to polar align at that point. Since you've converted the alt-azimuth into an equatorial mount, now you have the added complexity that you need to polar align the mount, which it's not hard to do, but it does take some more time. So some of the benefits of the fork-mounted Schmidt-Cassegrain sort of go away when you put it on the wedge, mostly the ease of use. So it becomes more complicated, and it becomes harder to set up just because of the weight that you have to lift up higher and put on the wedge. So this is where PrimaLuce has come up with a better solution for deep sky imaging, making the CPC DX HD powered by PrimaLuceLab an all-in-one system that works great for everything, including long exposure deep sky imaging. So at this point, I'm going to hand it over to Filippo, and he's going to talk about more about how they supercharge the CPC DX.
Thank you, Eric. As we just heard, the alt-azimuth problem has one traditional solution, the equatorial wedge. But with the wedge, you lose everything that makes the CPC so special. And I know this very well because I experienced it myself. Many years ago, I had the CPC telescope. And back then, it was the one with standard Schmidt-Cassegrain optics. I loved how easy it was. Set it up, power it on, start observing in minutes. For visual and planetary imaging, it was perfect. But when I wanted to do deep sky astrophotography, I had to add the equatorial wedge. And suddenly my easy telescope became heavy, complex, hard to align. I lost everything that I loved in the CPC. And that moment stayed with me for a long time. So when we started developing our solutions, I looked at the market and I thought about where the different telescopes sit. If we build a chart with easy of use on the horizontal axis and user control on the vertical axis, we can immediately see two different worlds. On one side, do-it-yourself setups. Powerful, fully customizable, you can use any accessory, camera, and software you want, but complex to assemble, difficult to manage, steep learning curve. Not everyone wants to spend months configuring a system before using under the night sky. On the other side, smart telescopes. Extremely easy to use, but with limited control, closed system. You cannot go beyond what the manufacturer decided for you. And they are not designed for visual observing or high-resolution planetary imaging. Two paths. Both ask you to compromise. Either you accept the complexity or you accept limitations. But we didn't want to accept that. And we had a clear starting point, the alt-azimuth mount. Because alt-az is simple, intuitive, fast to set up. It is the mount that makes the telescope accessible to everyone. And we wanted to keep all of that and solve the only limitation that was holding it back for deep sky astroimaging. So we asked ourselves, what if we develop a third option? So we started working. And the first challenge was the biggest one. How do we eliminate field rotation in real time without a wedge and without polar alignment? We needed two things working together. An hardware that physically rotated the camera to compensate the field rotation, and a very easy to use software that calculates exactly how fast to rotate it at every moment based on where the telescope is pointing in the sky. So we developed both Arco camera rotator and field rotator and play astrophotography software. The second challenge was the focuser. The CPC Deluxe HD uses an internal focuser, which has backlash and mirror shift, not ideal for precise astrophotography. We already had Esatto, our precision robotic focuser, in a low-profile version. But we wanted to make a more affordable option too, for users who want to keep the telescope native focuser. So we developed Sesto Senso 3 SE, a special version of our focus motor for SC telescopes. Arco can be used with the Sesto Senso 3 SC exactly like the Esatto focuser. The third challenge was auto-guiding. The EdgeHD has a long focal length, and you need auto-guiding to correct the tracking errors during long exposures. The classic solution is an off-axis guider, which is ideal for long focal lengths. But on a fork mount, the guide camera can collide with the arms. So we needed a guide scope in parallel, but it had to be compact, lightweight, and it had to work without an additional derotator on the guide camera. We developed a procedure that takes advantage of PhD guiding sub-pixel guiding, and that allows us to use a very compact guide scope installed in parallel to the EdgeHD telescope to allow long exposure imaging on alt-az configuration. This configuration allowed us to capture up to 4 minutes exposures with the EdgeHD 8 inches and f7 reducer. So over the years, PrimaLuceLab had developed all the technologies needed: a field rotator, a precision focuser, and integrated software. And there was one telescope that I had loved since I was young, the one that gave me so much joy for visual and planetary work, but that always had that one limitation. The technology was ready, the telescope was waiting. It was time to bring them together. The result is a telescope that can do everything: visual observing with all the power of EdgeHD optics and the GO2 system, high-resolution planetary and lunar imaging, where the long focal length of the EdgeHD is a real advantage, and deep sky long exposure astrophotography enabled by ARCO and PLAY without any equatorial wedge. It is available in 3 sizes: 8 inches, 9.25 inch, and 11 inch, to fit the different needs in terms of performance, portability, and budget. So every configuration of the CPC Deluxe HD powered by PrimaLuceLab telescope starts with the base kit. You can choose between 2 options: the Sesto Senso 3 SC combined with ARCO, a smart focus motor that motorizes the internal SCT focuser paired with the field rotator, or Esatto combined with ARCO, our precision robotic focuser that replaces the telescope focuser entirely, eliminating backlash and mirror shift, also paired with ARCO. Both options give you full focusing and the rotation control through Play software. And if you want to go further, there is the optional Eagle expansion kit. It adds the Eagle computer, which is a full Windows PC with integrated power distribution and advanced sensor. It has the 60mm compact guide scope, which works both as a guide scope and as optical finder, plus the plus dovetail system to support everything in parallel with the telescope tube. With the Eagle expansion kit, the CPC Deluxe HD becomes a remotely controlled observatory. One powered cable to the telescope and everything is connected. So here's the complete picture. CPC Deluxe HD in 8-inch, 9.25 or 11-inch. You can choose your preferred base kit with Sesto Senso plus ARCO or Esatto plus ARCO. This way, your telescope can be controlled from any standard Windows computer, where you will install Play. Then, if you want an even more advanced integration for deep sky astrophotography, you can add the optional Eagle expansion kit. Just note that the Sesto Senso 3 SC cannot be used with the 9.25-inch telescope, so this model can be used only with the Esatto plus ARCO kit. And this is what it looks like. On the left, the 8-inch with the base kit only. On the right, the same telescope with also the Eagle expansion kit. Same telescope, different capabilities. And an important note is that the camera is not included with the telescope, since the system allows you to choose the camera you prefer among the ones supported by Play. Remember the 2 paths that I showed you at the beginning? Do it yourself, complex but powerful. Smart telescope, easy but limited. The CPC Deluxe HD powered by PrimaLuceLab is the third option. As simple as the original telescope to set up and use, but open, upgradable, and capable of everything from visual to deep sky imaging. So let me show you how a deep sky session actually works with this telescope. After you launch CPWI and connect it to the mount, you connect the mount, camera, focuser, and rotator to Play. You use the integrated planetarium to point and track your object. The focus and rotate tab gives you full control of the focuser and rotator in one interface. You can run the auto alignment to plate solve your preview and confirm you are exactly on target. Play can suggest the best target for your location and time. You can start auto guiding with PhD guiding. Shoot a preview, and when you're happy, you launch your sequence acquisition with auto stacking enabled. And then you watch. The object builds on your screen, frame by frame, enhancing in real time during acquisition. And switching to visual is instant. No need to disconnect anything. All cables remain in place. You just remove the camera and insert your eyepiece. If you previously installed the focal reducer, that's the only accessory you have to remove before connecting the eyepiece. If you start your session with an eyepiece for visual observing, you just remove it, insert your camera, and you're ready to capture the moon, planets, and deep sky object by adding the optional focal reducer. Here are some examples of high-resolution planetary images taken with this system. And here's some deep sky imaging. No processing. This is what you see on screen during capture. And note that the same camera used for planetary images was used here. So one camera, two completely different uses. So this telescope is not a plug-and-play smart telescope. It is a real telescope with several accessories that required an initial configuration. But once you go through that configuration, and once you have the right knowledge, it becomes easy and fun to use every night. This is why we created a dedicated integration and first setup manual for every single model of the CPC Deluxe HD powered by PrimaLuceLab. Not just the user manual of single parts, but a complete guide that explains how to put the system together and use it from day one. And we also provide my book, Explore the Universe Through Astrophotography, that covers everything from visual use to advanced astrophotography, explaining what, why, and how. The manual also covers the topics that are often ignored but make a real difference in practice. Weight balance, which is critical on a fork mount. Auto-guiding strategies with suggestions specifically dedicated to the CPC Deluxe HD configuration. And here are the real-world numbers. So with the ARCO and the auto-guide scope included in the Eagle expansion kit, we achieve a sub-exposure of 3 to 4 minutes on the 8-inch and 2 to 3 minutes on the 11-inch. ARCO tracking accuracy is 1 arc second, and all PrimaLuceLab devices are full ASCOM compliant, so the system is open. And this is the philosophy behind everything we do. Simple to use, but not limited. Set up in minutes, just like the original CPC. No polar alignment, no counterweights, no equatorial wedge. Connect to play, and the rotation starts automatically. And at the same time, a system where the user grows with the telescope. You start with visual, you move to planetary, then deep sky. Same setup, every step of the way. The CPC Deluxe HD powered by PrimaLuceLab is the telescope that lets you grow. Visual, planetary, deep sky, always the same setup. This is the telescope I wished I had 25 years ago. And today, I'm proud and happy that PrimaLuceLab developed it together with Celestron. And as usual, clear skies!
Thanks, Filippo. We're really happy with how the project turned out. and PrimaLuceLab has really supercharged the CPC Deluxe HD, and we're really excited to see how people are going to be using it in the field. Thanks so much.
Thank you, Eric.